All right, so we're moving on to our next topic in the discussion of functions, and this is going to be the issue of function notation. So this is a way of representing a mathematical function that we are going to use all year long. It can sometimes feel a little bit abstract, so I want to go kind of slow in this video just to make sure you realize exactly how it's working. Once you get the hang of it, it's really not that complicated, but because it is somewhat abstract, sometimes it takes students a little while to get used to it. So in this video, I'm going to show you what it is, but really this is going to be the example video. We're going to talk about how you use it, and we're going to look at 2 or 3 or 4 different examples. We'll just see how much time we have, so you can see exactly the way function notation is working. All right, so with that said, let's take a look at our learning objectives. Learning objectives for this video are to be able to read and interpret function notation, and then to use function notation to find and express the value of a function. All right, so let's start with, what does function notation mean? So remember, we talked about that a function is a special kind of relation. Okay, this is a definition that you should know. In fact, this might be an excellent time to just review that definition. So maybe if that's not fresh in your mind or right on the tip of your tongue, maybe pause the video for a second, flip back in your notes, and find that definition. Make sure you know what a function is. That's a definition, probably the only definition that you're going to need to know this year. All right, hopefully you found that definition. The definition of a function is that it is a special kind of mathematical relationship where every input produces a single output, exactly one output, the same output every single time. Okay, so that's what we're talking about, is we're talking about functions. Remember, a relation is a rule, and you can describe a relation using ordered pairs. You can describe it with a table, with a graph, and with an equation. And when we're talking about function notation, usually it's the equation that we're looking at. Usually it's the equation, okay? So that's what I'm going to start with, is let's look at some equations. Now, for right now, I'm just going to tell you that this is a function. I'm not going to ask you to try and prove it or verify it or anything like that. I'm just going to tell you this is a function, all right? So here is an equation of a function. Y is equal to 2x plus 3. Okay, now the first thing I want you to notice is that in this equation there's 2 variables. There are x's and there are y's, which means that's something that I can graph. That's one of the clues that helps me to know that it's a function, the fact that it can be graphed, right? Because that's one way to represent functions. And the other thing that I notice is that the y is all by itself. This has been solved for y. Okay, so if you have an equation where the y is all by itself, then this is called function form. Okay, function form. So we call this function form. So we also, if you think back to the different kinds of equations that we studied, in the equations and the expressions and things that we studied, we talked about standard form for different kinds of equations. Well, function form is sort of like that. What makes something function form is that the y is all by itself on one side, and then everything else is in standard form on the other side. So remember, this is like standard form for a polynomial, right? This is standard form for a linear expression, right? So I've got the y all by itself, and then this expression is in standard form. It's fully simplified. All the like terms have been combined. The exponents go down from biggest to smallest with a constant at the end. Okay, so I've got standard form for the expression equal to y, and y is all by itself. When we get that, that's called function form for the equation. Okay, now the reason we call it function form is because this is what turns into function notation. So I'm going to take this exact same function and I'm going to rewrite it in function notation. So function notation for this equation is. Okay, now here's what function notation is going to look like for this equation. Half of it is going to look exactly the same, more than half. Everything from the equal sign to the right is going to look exactly the same. That part is exactly identical. There's no difference. The only thing that changes is the part on the left-hand side. Where I used to have a y, now I'm going to have something that looks like this. Okay? That's what ends up on the other side. So the y gets replaced with this stuff right here. And then everything else is the same. That's the reason why we call this function form, because it's almost function notation. And it's easy to see how to turn this into this. You're going to replace the y with this stuff. Now, what is this stuff? Well, that's the purpose of this video. So we're going to get to that. But this is just recognizing what function notation is. It's a simple equation where I've replaced the y with this stuff. So here's the first thing that I want you to recognize about function notation, to try and make it a little bit less abstract and a little bit easier to think about and to consider. Okay, y and f of x is how you would say that, f parentheses x. You would say that as f of x. We'll get to that in a second. Y and f parentheses x are the exact same thing. They are the exact same thing. So think about everything you know about y. F of x is the same thing. F parentheses x, that we say this as f of x. It's the exact same thing. So we know that y represents the range values, the outputs from the function. We talked about that in yesterday's video. So that means f of x also represents the outputs, the y values of the function, okay? We know that you can plug a number in for x to figure out y. So that means I can plug a number in for x to figure out what the function is, okay? These things work the exact same way. So that immediately raises a question. Well, if they work the exact same way, then why would you ever want this? It looks more complicated, it looks more scary. Why would you ever want this instead of that? Okay, and there's several different reasons, but there's two main reasons. And the first reason is really what we're going to introduce, what that thing is. So what is it that we're replacing y with? Okay, all it is, very simply, the easiest way to think about it is f of x is the name of the function. Okay, so here's one reason why you might want to use f of x instead of y. So think about a situation where I am working with two different functions. You don't need to write this down right now if you don't want to, but just think about this with me. Just kind of follow along with me. So maybe put your pencil down for a second and just watch for a minute. So suppose I have this equation that we've already written down, and then I have another equation over here. And I want to talk about those two equations. So maybe I ask you a question like, okay, they're both functions. Which one of those functions crosses the y-axis at 4? Okay, so it's easy to say this one by pointing to it, or it's easy to say the one that ends in 4 or something like that. But if I have lots of functions, or if I ask more in-depth questions, it can become difficult to distinguish, am I talking about this function or am I talking about this function? So one of the advantages of function notation is we use this to give us a name. So what I do is I just name the two functions something different. So now if I say which function is the one that crosses at 4, you could just say function g does, because this is the only function that has a g. This one has f instead. So that's one way that you could do this. These two things do the exact same thing. They mean the exact same thing, but this gives me a way to distinguish this particular function from a different particular function. Okay, so that's one way you can think of it, is it's the name. So if you think of it as a name, then just like we have, you get two names. You get a first name, you get a last name. The first name you get to pick, but the last name you don't, right? So when you're working with functions, the first name Here the first name is F. Here the first name is G. The first name, the mathematician who invents the function gets to name it, okay? So F is most common just because it's function, so function F, right? That's the most common name, so this is like the John of functions right here. It's a super common name, all right? But you can have function G or function H or function A or function B or whatever, whatever, okay? It's completely up to you what you want to name it. Now, the last name you don't get to pick, right? So when you were born, your parents probably could spend a lot of time figuring out what your first name was going to be, but most likely for your last name, they just gave you the same thing that they had, right? That's probably how it worked. Well, in math, the last name is the thing that's in the parentheses. And that thing has to match the variable in the equation. They have to match. So if my equation has an x in it, which we talked about yesterday, that's normal. That's the standard convention, is that you put x's in it. If my input variable is an x, then that's what has to go in the parentheses as an x, okay? Now, if I had some other function that maybe the input variable was a t, then right here would have to be a t, and I would name it g of t is what I would do, okay? But whatever my input variable is, that's what has to be the last name. That's what goes in the parentheses, okay? So the last name, those two things have to match. There's my last name. And now with functions, functions are boring because they all have the same middle name. Every single function, everywhere in the world, the middle name is of, okay? So this is f, because that's the first name, of, because every function has of for its middle name, and then the last name is x, f of x. And so that's how we would say that. So really, in a real sense, that's all functions are doing, is functions are giving us, or I'm sorry, function notation, that's all function notation is doing, is it's giving us a name, a way to talk about functions. So if I have lots of functions that I'm working with, I just give them all a different name, and then I can say, okay, I want you to plug 3 into function f. And if I say that, you know that I mean plug it into this function. And then I want you to plug in 2 to function g. So if I say that, you know that you're plugging 2 into this function. All right, so that's the first thing. F of x is just the name. Now, here's the second thing that we can do. Function notation also provides us with a way to describe an ordered pair. Okay, function notation can also provide us with a way to describe an ordered pair. So I'm going to come back up here to function f for a second. So if I write it like this, f of x equals 2x plus 3. Now to see how I can use this to describe an ordered pair, I'm going to have to do a little bit of work. I'm going to have to show you a little bit of stuff as we go. Okay. The first thing I'm going to have to do is I'm going to have to explain to you what does it mean if somebody were to come along and instead of writing f of x, write something random like f of 4. Okay, suddenly they've changed the last name from an x into a 4. So what does that mean, or how do I handle that? Well, remember, we just said up here, whatever's in the parentheses has to match what's in the equation. So they took out this x and they put in a 4. That means in the equation, I'm going to take out all the x's that are in the equation, and I'm going to replace those x's with 4s. So just like we've said all year long, when you substitute, you're going to use parentheses while you substitute, and all that's going to happen is that this x is going to become a 4. That's what's going to happen. So whatever is in the parentheses over here, the same thing is going to go in the parentheses over here. All right, those are going to match. Now, when I do that, I end up with an expression that I can simplify. I can figure out what this equals. So 2 times 4, that equals 8. And then 8 plus 3, that equals 11, right? Order of operations, I have to multiply first and then I add. So 2 times 4 gives me 8, then I add, I get 11. So on the right-hand side, I simplify this down, I just get 11. So notice what I have. I have an input of 4. I inputted 4. And once I simplified that, I got an output of 11. The 4, when I combined it with this stuff, turned into an 11. Okay, so that's what happened on this side. On the left-hand side, there's nothing to do. I'm just going to leave that, whoops, that's a 4, exactly the same as it was. I'm not going to change anything on the left-hand side. So now I have this new expression, f of 4 equals 11. So what I've done is I've used function notation to evaluate an output based on a certain input. So when I inputted 4, I found that the output was going to be 11. Now, remember, the inputs are my x values and my outputs are my y values. So these two things, if I take them together, make an ordered pair. The input is my x value, the output is my y value. And notice that's exactly what we end up with here. My input and my output. So this is just another way of representing an ordered pair. Okay, so it's just a different way of showing I plugged in a 4, right? Both of these are showing I'm plugging in 4, and both of these are showing I got out an 11. So this is a different way. Now, again, why would I ever want to do that? Well, if I'm working with multiple functions and I just say 411 is a point, 411 is a point for which function? Well, I can't tell from this. But here it makes it clear. 411 is a point, and specifically it's a point for function f, because I can still see the name. Here I can't see the name. Okay, so that's the big idea with function notation. And that's really everything that we're going to need to know about function notation for our class. So as far as our notes go, that's basically the end of our notes right there. How do you read and interpret it? Well, you read it by saying the phrase f of x or g of x or something like that. And you interpret this as being just a name. F is telling me what function I'm talking about. X is telling me what the variable is where I'm plugging things in. What's my input variable? Okay, so that's my first learning objective. How do I read and interpret the function notation? And then how do I use function notation to find and express a value? So that's exactly what we did right here. Once I saw f of 4, I knew that meant plug in 4 and simplify. So that's finding the value. And then expressing the value, I'm doing that right here just like I would with an ordered pair. But now my expression includes the name of the function. So it's a more useful way to represent that information. Okay, so that's everything in our learning objectives. So like I said, what I want to do now is just spend a few minutes and go over a couple examples. All right, so with each one of these examples, what I'm going to ask you to do is write down the problem and pause the video to work through the example. Once you've got the example worked through, then resume the video. So we're going to do 3 examples all together. And for these examples, we're going to use 3 standard functions. We're going to have f of x, and it's going to be the same f of x we had just a second ago. We're going to have g of x, and that's also going to be the same g of x that we had just a second ago, so I'm not going to change those. And we're going to introduce another function, h of x. So we've got 3 functions altogether. And we're going to use these 3 functions to find as 3 different examples. All right, so here's example number 1. Example number 1 says find f of -2. Find f of -2. So what I want you to do now is pause the video and do that. Okay, so hopefully you've done that. So the first thing you should recognize is of the three equations that I have here, if I'm asking you to do f of -2, that means you're going to use the first equation. You're not using all of them. You're only using the equation that has the first name of f. So f of x is 2x plus 3. Now what I'm going to do is I'm going to replace the x with the number -2. And I'm going to do that every place there's an x. Now I just simplify over here using order of operations. So that's 2 times -2, that's -4. And -4 plus 3, that's -1. So f of -2 is equal to -1. And that's my answer. I'm done. F of -2 is -1. Okay? Now remember, this is the same as being an ordered pair. So probably coming soon to a math class near you, I could turn this into a table. I could turn this into a graph. All the same things that we do with ordered pairs, we can do those with functions. Okay? But for right now, we're just going to stop right there. So here's example number 1. Example number 2. Find h of -1. H of -1. So pause the video right now and do that, please. All right, so hopefully you found that. Going back to our 3 equations that we have up here, the first thing I have to do is decide which equation am I going to use. And the answer is we're going to use the one that has a first name of h. So that's this one right here. So h of x, just copying this from up above so that it's down here where I can see it better. That's h of x. The first thing I want to do is everywhere where there's an x, I'm going to replace that x with the number -1. Okay, everything else stayed the same. And just like we've been saying all year long, when I substitute, I'm going to use parentheses. In fact, I kind of like with functions, notice how the parentheses here exactly match. Okay, I think that's a nice feature, a nice reminder of function notation. It's a bonus feature, I feel like. Okay, so now we're just going to go through and we're going to simplify this using order of operations. So the first thing you have to do in order of operations is you have to do exponents. Okay, I've got parentheses, but there's nothing inside the parentheses that needs to be simplified, right? So since there's nothing on the inside to simplify, I move on to exponents. -1 squared, so that's -1 times -1. I'm going to get +1 when I do that. That's my only exponent, so now I move on to multiplies. I've got a 2 times -1. That equals -2 when I do that. And then I can move on to my adds and subtracts. And adds and subtracts we just do from left to right. So 1 plus -2, that's going to equal a -1. And then -1 minus 4, that's going to end up being equal to a -5. -5. And so there's my answer. H of -1 is equal to -5. All right? All right. Final example, example number 3. For this one, what I'm going to ask you to do is to figure out what is g of 16. G of 16. So again, pause the video real quick and try and find that answer. Okay, so hopefully you found that answer. Again, just like before, the first thing I want to do is figure out what equation am I using. I'm using the equation that's named g, so that's this equation right here. So g of 16. In this equation, I'm going to replace the x with some parentheses, and in those parentheses, I'm going to put the number that's over here, 16. So now I just use order of operations. -1/2 times 16, that's -8. And then I finish with adding these together. -8 plus 4, that's -4. So g of 16 is equal to -4. I'm sorry, you couldn't see that. There we go. I apologize. But hopefully you already had that anyway. So hopefully, even though you couldn't see what I was writing, you could follow along with me on your paper because you already did that. And hopefully you did it correctly. So I did my substitution. My x's turned into g's, right? Because originally we had g of x was equal to -1/2 x plus 4. So I turned my x's into 16s, and then I simplified 1/2 and 16, those multiplied together, and then these add, and that's how I ended up with -4. Okay, so that is function notation. And that's the extent of function notation that we will be needing in our class. So be able to read it and interpret it, and then find values and express values. All right. Oh, one last thing that I want to mention, again, just to make sure that I'm clear on this, I almost forgot. When you express this, remember that the number in the parentheses is your input. So this is your x value or your domain value. And the other number is your output. So this is your y value or your range value, okay? This name is the same as having a G. It's the same as having a G. So I could have just as easily, I'm sorry, it's the same as having a Y, right? So if G of X is -1/2 x plus 4, then that's the same as having Y as -1/2 x plus 4. And so if I'm supposed to plug in 16, then I need to make sure that I remember all that math is going to be exactly the same. And what I'm going to end up with is y equals -4. So I'm just trying to remind you, reinforce the idea that the G and the Y, they're saying, they mean the same thing mathematically. The difference is this one communicates a name, so it helps me to identify which equation I'm working with when I have a group of equations. Okay, so with all of that said, I think we are done with this video. Thanks for watching. Have a good one.